This is an experiment we did to see if it was possible to isolate cyanogen iodide without killing ourselves. We had some crude mixed sodium-potassium cyanide salt which was starting to hydrolyze and nearing its shelf life. So we measured out 10 grams of this, assuming that it was maybe 70% pure. You can see it's a nasty yellow color. Next we weighed out 30 grams of solid iodine. We figured that if the cyanide was 70% pure, then we'd see if we could use 3/4 of the stoichiometric amount. We measured out 30 ml of water. We added this to the cyanide salt and then stirred gently to dissolve. This all went into solution pretty easily. We then added this solution to a 250 ml flask, equipped with a magnetic stir bar. And we placed this in an ice bath and allowed the temperature to drop to 2 degrees C. With stirring on, we then slowly started adding the iodine. You can see a white smoke appearing in the flask instantly as the iodine is added. This is probably cyanogen iodide vapor, produced by the iodine vapor and a small amount of hydrogen cyanide present. We don't recommend sniffing to find out. The iodine color disappeared pretty quickly, and we continued addition. We got about 3/4 of the way through the iodine when a persistent iodine color was present in the flask, so we stopped addition at this point and allowed to stir for 10 minutes. We then measured out 40 ml of dichloromethane. We added this to the flask and stirred for another 10 minutes. The idea was to try to dissolve as much of the cyanogen iodide in the solvent as possible. After this time we allowed the layers to separate. You can see there's also a fair bit of white precipitate in there. We prepared an ice-cold separating funnel, and then added the contents of the flask to this. 2 clear layers separated, and strangely enough it was the top layer which was our organic dichloromethane layer. This suggested there's still a lot of product in the bottom layer. So we separated off the bottom layer and reserved it. We then separated off the top dichloromethane layer. We returned the aqueous layer to the flask again and added another 20 ml of dichloromethane. As before, we stirred for 10 minutes to allow the product to dissolve. This time the white precipitate had disappeared, and it turned out that the organic layer was actually the bottom layer. This took a while to separate. We dried off the bottom layer and added this to our previous dichloromethane extract. And we added a small amount of magnesium sulfate to dried it. We let this sit for 15 minutes and then transferred into a 250 ml flask. We then set this up on a room temperature water bath attached to a vacuum to see if we could draw off the solvent. We used a cold trap on the pump and also a hose from the pump outlet leading to the extractor fan. This is important, as you'll see. The solvent slowly came off, but we also started to notice beautiful long white needle-like crystals forming in the flask and in the outlet. This stuff is really volatile. We were losing a lot of product and we were worried about the health risk, so we stopped when a small quantity of solvent remained. We chilled this right down and then set up for filtration. This did result in a small amount of brown powder being isolated and dried on the pump. You can also see a lot of black tar-like impurity forming. Here's our crude crystals, not a lot as you can see. The rest of the product seemed to polymerize into sticky, black iodine-containing tar in the filtrate. Unpleasant and hard to wash out. We heated some chloroform to boiling point on a hot plate, and used this to quickly dissolve the crystals. It took around 15 mils in total. We then allowed the mixture to chill down and crystalline solid precipitated out of the solution. We filtered this off and then washed with 2 portions of 10 mils of ice-cold chloroform. Here you can see the black tar appearing on pretty much any surface the product came into contact with. Here's our final product, just a few grams of cyanogen, iodide. We couldn't get all the black color out, but it's a light tan color, and if you look closely the needle-like crystals are visible. This is a tough preparation. The product is extremely volatile, and decomposes rapidly into black tar. We were most impressed, however, with the incredible crystals in the flask. Stay tuned for more videos.